Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing awesome. Let's go ahead and get this thing started with a word of prayer. Dear Heavenly Father, thank you for this day. Thank you for all you do. I pray you'll bless us with a good day. Help us continue learning. In Jesus' name we pray, amen. Hi guys, so today we're going to be learning how to use similar polygons. This lesson is 6.3, page 372. Two polygons are similar polygons if corresponding angles are congruent and corresponding side lengths are proportional. In the diagram below, polygon ABCD is similar to polygon EFGH. You can write ABCD is similar to EFGH as ABCD is similar. That's what this little squiggly sign says. EFGH. Notice in the similarity statement that the corresponding vertices are listed in the same order. So this is the similarity statement, okay? Let's keep going. Example 1. In the diagram, triangle ABCD is similar to DEF. So, list all pairs of congruent angles. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. Angle C is congruent to angle F. Okay, check that the ratios of corresponding side lengths are equal. So let's go ahead and take a look at AB compared to DE. AB compared to DE. If we reduce 25 over 35, simplify that, both of those are divisible by 5 and can reduce down to 5 over 7. Okay, let's take a look at BC and EF. 20 over 28, both divisible by 4. Oh, sorry, let me write this down. BC over EF equals both divisible by 4, which will reduce down to 5 over 7, which is good because for these to truly be similar, their proportions should all equal 5 over 7. So if you're a betting person, 30 over 42, which is AC over DF, should reduce to be 5 over 7. And it does because if you divide by 30 by 6, it'll be 5, and 42 divided by 6 would be 7. Okay, write the ratios of the corresponding side lengths in a statement of proportionality. A statement of proportionality is simply this. AB over DE equals BC over EF equals AC over DF. And you just write that down. So AB over DE equals BC over EF, which equals AC over DF. Okay, let's go ahead and keep going. Scale factor. If two polygons are similar, then the ratios of the lengths of the two corresponding sides is called the scale factor. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of RSTU to DEFG. So we can see that they have all congruent corresponding angles. So that's good. Now we need to check their corresponding side lengths to see if they're proportional. 30 over 20 is a really easy one to start with. We would reduce down to 3 over 2. So all the other side lengths need to reduce down to 3 over 2. Okay? So 27 and 18 is going to reduce down to 3 over 2 because both of these are divisible by 9. 9 divided by 27 is 3. 18 divided by 9 is 2. The way I like to do it is what times 3 is going to give me 27 once I know that 3 is going to be my base number. So for here, 33 and 22, what times 3 equals 33? 11. So if we divide this by 11 and this by 11, hopefully we get 3 and 2. 33 divided by 11 is 3. 22 is 2. Okay? And 12 and 8, both divisible by 4 to give you 3 over 2. Okay, so that is awesome. real quick, with that, we know our scale factor is 3 to 2. Now, they want us to write a similarity statement. And our similarity statement is really easy to write. All you do is replace this word with a squiggly line. RSTU is similar to DEFG. Okay, that's all. Let's go ahead and keep going. Example 3. In the diagram, triangle ABC is similar to GHJ. Find the value of X. So to do that, you need to find two sets of corresponding sides. One of the sets obviously needs to contain your X value, and the other one, it doesn't matter. So I'm just going to pick 12 and 8. So right here, we're just going to write 12 over 8 equals X over 16. And to solve this, all we're going to do is use the cross product property. So 12 times 16 divided by 8, and that's going to give us X equals 24. I'm not going to go ahead and work that math out. It's something we've been doing this whole chapter. But we just 12 times 16 divided by 8 gave us 24. Okay? The ratios of lengths in similar polygons is the same as the scale factor. Theorem 6.1 shows this is true for the perimeters of the polygons. Perimeters of similar polygons. If two polygons are similar, then the ratios of their perimeter is equal to the ratio of their corresponding side lengths. Okay. So, if you add up all the sides and set them over each other, it's still going to be equal to one side over one side. Okay? That's a lot of side wordage. Side, side, side. Okay, let's keep going. You are constructing a rectangular play area. A playground is rectangular with lengths 25 meters and a width of 15 meters. The new play area will be similar in shape but only 10 meters in length. So the first thing I like to do with a problem like this is let's go ahead and draw a schematic of this. Okay, so we have our playground and then our play area. Our playground is 25 in length, and our play area was 10 in length. So I'm just going to go ahead and write a small 10 right there. And our playground is 15 in width, and our play area is who knows what. We don't know, but I'm sure we're going to find it out. So the first thing they want us to do is find the scale factor of the new play area to the playground. So that's going to be 10 over 25, which both of those are divisible by 5, which would give us a scale factor of 2 over 5. Because 10 divided by 5 is 2, 25 divided by 5 is 5. Okay. Now they want us to find the perimeter of the play area and the playground and the play area. Well, finding the perimeter of the playground is straightforward. It's going to be 25 times 2 plus 15 times 2. So let's go ahead. I'm just going to write that down. 25 times 2 plus 15 times 2. So we have 50 plus 30. So we have 80 meters is our playground's perimeter. So now they want us to find the play area. And there's two ways we could go about this, but because we just learned the perimeters of similar polygons, theorem 6.1, I believe, we're going to go ahead and use that. So we know that our ratios, our scale factor is 2 over 5. Okay? We don't know the perimeter of our play area, but we do know the perimeter of the playground. So now if we just simply solve this, that'll give us the perimeter of our new play area. So 2 times 80, 160, divided by 5 would give us 32. So the play area's perimeter is 32 meters. Okay? We could have solved for this x value up here, which are two different x values, by the way. We could have solved for this and then did 10 times 2 plus whatever this value is times 2 and added those together. And we would have got the same answer. But I just wanted to use our new theorem because why not, you know? Why are we learning them if we're not using them? So, similarity and congruence. Notice that any two congruent figures are similar. Their scale factor is 1 to 1. In triangle ABC and DEF, the scale factor is 5/5, which is equal to 1. You can write triangle ABC is similar to triangle DEF, and triangle ABC is congruent to triangle DEF. Corresponding lengths. You know that the perimeters of similar polygons are in the same ratio of corresponding side lengths. You can extend this concept to other segments in polygons, okay? Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygon. So, in the diagram, triangle MNP is similar to triangle RST. Find the length and the altitude of NL. So, they want us to find the length of the altitude NL. We don't know that, but we do know that MN, let's just pick MN, is 30, and RS right here is 20. Okay, we know those two sides are similar, which makes them proportional. That's going to reduce down to 3/2. Okay, I'm going to write that right here, 3/2. Now we know we can make a proportion using that, and we know that the altitudes are also going to be similar from the corresponding lengths in similar polygons that we just learned. So we don't know the value of NL, so we're just going to call that X. But we do know the value of LS, which is similar to NL, and that's 14. Well, now all we have to do is cross multiply 3 times 14 and divide that by 2, and we're going to be left with 21. Okay? So the length of NL equals 21. Okay, guys? That's all. That was the whole lesson. I hope that made sense. I hope you're keeping up. And you know what? You guys just have a great day. See ya!